Okay. In our previous class, we have completed second module. Now let me to go to next module, that is third module, which is called as artificial neural network. And I think in the very first class, I have already shown you how exactly these artificial neural networks look like. Okay, so there is some input layer and then is output layer, and in between this input and output layer, some hidden layers will be there. And why we should call them as a hidden layers today I am going to tell you. Okay, see before going to exactly directly to the module 3, so let me to show you once again these neural networks. Okay, see, uh, neural network is a network of neurons. As its name itself is a network of neuron. So neurons means nothing but nerves. Nerves in our brain also nerves will be there. Similarly here also in artificial neural network there are some human created networks of nerves are there. So they named it as a neural network. And why they have taken this concept only, these all things based on or inspired by our biological nerves only, and biological nervous system. So how our brain works similarly, that machine also should work, so that they have taken this word from our biological word only. Okay, see, since there are so many number of nerves are there in our brain, and all are interconnected like zigzag zigzag, so many nerves are interconnected. Similarly here also we are interconnecting these all nodes with, or you can also call them as units. We are interconnecting them with some edges. So since it looks exactly like our nervous system, so they name it as a neural network. So here the neural network is therefore it is a biological neural network, which is made up of real biological neurons, or else it is a artificial neural network. And these artificial neural network are used to solve some problems, particularly which problems? Artificial intelligence problems. So because of that only is called artificial neural network. It means that artificial intelligence and deep learning and machine learning difference also I told you in the first introduction classes. Right? So these all problems which we solve in artificial intelligence, we can solve these all problems with this neural network. Okay. See, this is a simple neural network. One input layer is there, or the output layer is there, and in between input and output layers, one hidden layer is there. And here, whatever the circles are there, these circles are called as nodes or as unit. Okay, you can call it as unit. So this is also one node, that is output unit. So it means that in hidden layer, whatever the units are there, they are taking some inputs from these input units. Okay, and the outputs of these hidden layer or hidden units are again inputs to the next unit in the next layer, that is output layer. So that these hidden layers take the inputs from the input layer, and the inputs to this hidden layer are output of input layer, and these hidden layers or hidden layer units will produce the outputs, which will be the input to the next layer unit, that is output layer unit. So this is a simple neural network. Then you can see some more complex neural network. That is here one input layer is there and one output layer is there, but here two hidden layers are there. Right? So these all are some simple to complex neural networks. Okay. So these all are interconnected here. So this is connected to next, 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 this is connected to next. So like this, if we connect these all units together, then it looks like exactly like our human brain nervous system. So we name it as like the artificial neural network. So then this is also one more one more simple neural network. So here also input layer is there. In this input layer, so many number of units are there. How many number of units are there? 1, 2, 3, 4, 5, 6. 6 units are there, and two hidden layers are there here. Two hidden layers are there, and one output layer is there, and there is only one output layer unit is there. Okay. So here this hidden layer is taking the input from this input layer, and it is producing the output, and that output will be the input to next hidden layer. Okay. Again, this hidden layer is producing some output which will be the input to next output layer. So this is the main this one, visibility, how exactly will the artificial neural networks look like. Okay. So then this is also one more very thick neural network, so we can call it as a deep neural network. So here we can observe so many number of input layer units are there, so many number of output layer units are there, and between these input and output layer, three hidden layers are there. These hidden layers again, they have some units with some inputs and some outputs. Okay. So many number of inputs this layer is getting, and similarly it is producing so many number of outputs. Similarly, those all outputs are input to these hidden layer 2, and it is also producing some many number of outputs which will be the input to this hidden layer, and it will produce the output which will be the input to next layer, that is output layer. Then these output layer units, only 4 output layer units are there, they will produce some outputs. Okay. So, this is still more complex neural network, artificial neural network. So it means that here 1, 2, 3, 4, 5, 6, 7 input layer units are there, but these 7 input layer units are producing so many number of outputs which will be the input to next layer, and then they will produce some outputs which will be input to next hidden layer, and they will produce some outputs which will be input to next hidden layer, and again in turn this hidden layer produces some outputs which will be input to this last output layer. We can observe here we have written, since it is an input layer I0 to I6, okay, 7 input units are there. Here since it is output layer, so it is O0 to O11, it means 12 output units are here total. Okay. And since these are hidden layers, so these are H1, H0 to H11, and H20 to H21, that is H we have it since they are hidden layers. So this is how exactly artificial neural networks work. So this graphic, so you can understand. So input layer is taking some inputs, and that input may be any image, any voice, or any audio, or any text. It may be anything. And once we give this input to this input layer units, the input will be taken by this input layer, and it will produce some output, so which will be in turn input to the hidden layer, and that hidden layer produces some output which will be in turn input to the next output layer. Okay. It means that here our animal, whether that animal is a cat or it is a dog, so our machine has to identify it, so that n number of images we have to just a second. ఎలా అడుగుతారు నిన్న క్వశ్చన్ అడుగుతారు ಅವ್ರು ಮತ್ತು ಮನೆಯಲ್ಲಿ ಏನು ಸಿಗೋದು ಎಲ್ಲ ಅವ್ರ ಮನೆಯಲ್ಲಿ మరి నిన్న ಕನ್ನಡ ದಿನ ಕೊಡ್ತಾರೆ ಪ್ರತಿ ಸಿಕ್ಕಿ ಕೊಡ್ತಾರೆ ಇವತ್ತು ಕರೆಕ್ಟ್ ಇವತ್ತೆಲ್ಲ ಕರೆಕ್ಟ್ ಯಾರು ಬೇಕು ಸೊ ಇದನ್ನ ಮಂಡೆಯಿಂದ ಮತ್ತೆ ನೀವು ಅದು ಮೆಜಿಂಗ್ ಶೀಟ್ ಐತಲ್ಲ ಅದು ಮೇಂಟೈನ್ ಮಾಡಿರಿ ಎಲ್ಲಿ ಟ್ರೈ ಮಾಡಿ. Okay, see here the input is taking as images of some dogs, then images of some cats also we have given to this, but when we test the machine, so if you show one real animal like a dog or anything, so based on that image what it has created inside this neural networks input layer or hidden layer and output layer, so based on these one pattern, pattern created for this dog. Based on that, it decides that this animal is a dog. Okay, so this is a once again this is a human biological neural or nerve, and this is an artificial neural network. So somewhat some similarity is there because of that only. So they have named it as a neural network. But this one is a biological, but this one is a artificial. Okay, so this is a brain, how our nerves are connected to each other inside our brain. Okay, like this, so many nerves, n number of nerves are there which are connected to each other, and based on these, we are able to take some decisions, important decisions in our day-to-day life. Okay, so now let me to start the third module, that is artificial neural networks. Okay, see, first we will complete this first topic, that is introduction. Then the second topic also I will complete today only. Okay. See, this neural network learning methods provide some robust or strong methods to us, that is approach. Why they are giving us these approaches? It means that which methods first you understand. These are neural network learning methods. Neural network learning means what? We are going to learn something with the help of neural network. Okay, and so we can call it as a first you develop the learning. What in the decision tree learning, what we say that learning is nothing but construct the decision tree. Similarly here, first we should construct or develop the network. Which network? Neural network, and particularly which neural network? Artificial neural network, because we are creating, we are developing that network. So we can call it as a artificial neural network. And based on that neural network, we are going to learn something to decide, to take some important decisions. So these all neural network learning methods are giving us some methods, that is robust method. Robust is nothing but a strong method. Why we are going to use these methods? To learn. We learn three types of target functions. Remember in your mind, we are going to learn, it means we are going to find out, or it means we are going to determine, or we are going to calculate three different types of target functions. What are those three different types of target functions? That is discrete value target functions, real value target functions, and vector valued target functions. And already I think you know this word, that is a discrete. It means discontinuous. Continuous opposite word is discrete. So discrete valued target function, okay, and real valued target function and vector valued target functions. To find out these type of target functions, this neural network is very suitable. Okay. For other types of problems, or different types of problems, such as learning to understand or represent some real world sensor data, also we use this neural networks. So in beginning only I told you this model is very interesting because in previous models just you studied some problems like checkers, playing water games, playing tennis, like this, with the help of some algorithms like candidate elimination algorithm, final failure algorithm, and this one, list then eliminate algorithm, and then ID3 algorithm, and then candidate this one. That is C4.5. Actually, you have not studied it, just you studied how it works, right? This is an extension to our basic ID3 algorithm. These all algorithms we have studied, right? So, but here now onwards you are going to study just some couple of examples which are very realistic in our day-to-day life. Okay, so because of that, I told you this artificial neural network model itself is very interesting for you people. Okay, so you can see here we are going to solve some problems, some complex problems which have some real world sensor data. It means that wherever in your project you are using some sensors, and with that sensor, whatever the data if you are getting, that is a real world data or real world sensor data. Whenever you do project with such type of sensors and sensor data, at that time we can use these artificial neural networks. Okay. So because here these artificial neural networks are one of the most effective learning methods to solve these complex problems which are using real world sensor data. So for example, here also we are going to use one very important algorithm in this module. That algorithm is a propagation algorithm. Okay, in the next topics I will discuss this back propagation algorithm and why it is called as back propagation. That also I will tell you. Okay, see, in this model we are going to use this back propagation algorithm, and based on this back propagation algorithm we can construct these artificial neural networks to decide some decisions or to take some decisions or also to solve some complex problems which use some sensor data. Okay, so this back propagation algorithm is a very successful algorithm to solve many practical problems like learning to recognize the handwritten characters. I think I have shown you in the introduction class in the first day or second day of this subject. That is, one second. Okay. Some handwritten characters to identify them. I have shown some examples there. If you remember, I had written some list of channels. Okay, and that one app is there. That app is trying to recognize what I have written. So such type of problems we can solve with the help of this back propagation algorithm. This algorithm is used by this artificial neural networks. And also there are some problems are there if we want to recognize some spoken words. It means that in mic we are speaking some words and our machine should recognize what I have spoken. It means that we have to pronounce properly the English and then it will identify what words, what sentences I am speaking. Okay, so such type of problems we can solve with the back propagation algorithm. In artificial neural networks. And also one more problem is a very interesting problem, learning to recognize the faces. Learning to recognize the faces. So for example, in your mobile also, you can unlock your screen with your face, right? So if you hold your camera, mobile camera in front of your face, then it will make a pattern, and based on that pattern matching, it recognizes your face. Then it will decide that this person is the owner of this mobile, and then it unlocks your phone, right? So such type of all problems we can solve with this back, back propagation algorithm in artificial neural network. Okay? See, then biological motivation. Why people have started to use this neural network and particularly artificial neural network. So it means that the main motivation was the inspiration from this biological neural network only. See, just now I told you this artificial neural network is inspired by the biological learning systems. So these biological learning systems are constructed with real or biological interconnected neurons or neurons, right? In our brain also we have neurons. Okay? So based on that only, this is inspired. So they have developed this artificial neural networks. And what about this artificial neural network? So these artificial neural network are built out based on some thickly and interconnected set of simple units. So just now I told you these all circles are called as units in artificial neural network. And in these units, each and every unit takes a number of real valued inputs. See the word what that author has used here. If you observe carefully, very nice subject it is. See what type of inputs it is taking? It is taking real valued inputs. Real valued inputs. Okay. See, then these inputs will be outputs of next layer. It means the units which are present in the next layer. And this produces a single real valued output. Again, that output unit produces some output. No, that output is a real valued output. And again, that may be inter input to next layer, the units of a next layer. So similarly, see here, this is a unit which is taking three inputs and it is producing one output. And again, this output may be input to next layer. Okay, so here these outputs may be input to next layer units, and then these layers also produce some outputs, and like this child will continue. Okay, so this is how the machine learning engineers are inspired with the biological neural networks. So when compare our neural network, artificial neural network with biological neural network. In fact, our artificial neural networks are faster than uh, biological neural networks. So because see, whenever if we are sleeping in our bedroom and in the morning if our mothers will make us to get up or will make us to wake then suddenly when we get up and we look into our mother, so we take some time to recognize that she is my mother or she is our mother. Okay, so instead of our mother, if somebody will come and will get make us to wake up, again we take some time and we decide, oh, she is my cousin, she is my sister, like this. Suddenly, so in afternoon, if you are sleeping and somebody, some guest will come to you, the guest may be your cousins or somebody who are meeting you after a long time. Suddenly, if they come and they will make you to get up, and you will get up and you will take some time to manage yourself, you will be surprised. So you will take some time whether it is a real or it is a dream, right? So you take some time, you take some seconds, and that time will be more than recognizing your mother, because your mother is staying daily with you people and daily she will make you to awake and you will get up and you will get ready and you will go to college. Of course, daily you will look at her and you will listen her voice and of course you will immediately recognize her. Suddenly somebody else will come and they will make you to awake. At that time you will take a lot of time to realize whether I am in a dream or in the real world. Okay, so these times are there. Based on these times are very very large or more comparative to our artificial neural network, because our artificial neural network takes very short time to decide these all things. Okay, see here our fastest neuron switching times. So fastest neuron switching times. So these switching times are 10 to the minus 3. 10 to the minus 3. It means that we we human being take 10 to the minus 3 seconds. 10 to the minus 3 seconds means how much? It is 0.001 second, okay, to recognize our mother, somebody else. Mhm. So this time, whatever this 0.001 is there, no? This is very very slow. Okay, it's very very slow when we compare with the computer switching speed or artificial neural network, because these computers are taking only 10 to the power 10, 10 to the power minus 10, that is 0.000000001 second. So which one is the largest and which one is the smallest here? That 0001 is a largest value and 0001 is the smallest value. It means that these computers are taking very less amount of time to decide. Okay, see, since these humans are able to make surprisingly complex decisions, complex surprisingly quickly. Of course, we make decisions and we make these decisions quickly also, but still more quickly than us machines can take decisions. So here sometimes if we are very much familiar, at that time we can take decisions very very immediately. It is 10 to the minus 1 or it may be 0.1 second. So now if you compare this 0.1 is very very large value comparative to this 10 to the minus 3 and 10 to the minus 10, right? So here comparative to human beings, these machines could be able to take decisions faster than human beings. Okay? See, uh, actually in our human brain, how many neurons are there? Approximately 10 to the power 11 neurons are there. It means 10 to the power nerves are there. And these all 10 to the power nerves, 10 to the power 11 nerves, 10 to the power 11 means one after the uh, if you write 11 zeros before this one, then it is called as 10 to the power 11, right? So these many number of nerves are connected to other set of nerves which are 10 to the power 4. That is 10,000 nerves. So if you just imagine, if you are connecting with all two sets of nerves in our brain, how exactly it looks like. The similar way, our artificial neural networks should also look like, and then only they can take they will be able to take decisions. Okay? See, our neural contains 10 to the power 11 neurons, and they are again interconnected with other set of 10 to the power 4 neurons. So these all things, almost these all artificial neural networks are inspired by biological neural network, okay, or nervous system. See, these all things, two groups of researchers have worked on these neural networks and particularly artificial neural networks. One group was completely, they were motivated by these biological learning processes, and the second group of researchers or engineers, they completely inspired or motivated so that they can solve very complex machine learning algorithms or machine learning problems or artificial intelligence problems. So with the help of these machine learning algorithms, the main motivation was two types here. Some people are there, they motivated based on this biological learning process. Okay, so some people are there, they wanted to really solve artificial intelligence problems based on this machine learning algorithms. So the goal was simply here obtaining or getting highly effective machine learning algorithms. And these machine learning algorithms are completely independent of our biological processes. It means that don't compare these machine learning algorithms with these biological processes. So these machine learning algorithms were completely independent of these biological processes. So that we call these all machine learning algorithms as artificial neural networks. Okay, so but our interest is not here. Our interest fits to not a biological learning process. Our interest is a second one, that is the latter one, that is second group. So therefore we are going to focus only on the machine learning algorithms. We are not focusing on biological modeling. We are not going to produce one brain here. Okay, we are just interested to solve some problems with the help of this machine learning algorithms. So just by keeping or just by inspired by our biological nervous system or neural system. So the second topic is neural network representations. Now onwards the actual topics to start here. Till now whatever I discussed it was just introduction. Yeah. So neural network representation. Just remember, since from first module we are using this word representation. Okay, representation. Target functions we have chosen there in first module, and also we represented that target function in the form of a recap. Then in the next module we started to use decision trees. Okay, so the decision trees are a representation of these target functions and hypothesis only, right? So here also we are going to represent these neural networks. So in the form of these input layer and output layer and other layers. Okay, so that only we are going to study here. So one very important, very interesting real-time problem I am going to explain you now. So that is nothing but we want to train our machine so that that machine itself should drive the real car. Okay, so that we can call it as a driverless car, automatic vehicle, autonomous vehicle. That problem I am going to discuss now in this topic, that is neural network representation. Okay, then if you consider this example or problem, driving car, autonomous vehicle or driverless car, then you will understand how we use this neural network, where we use this neural network, and what is the representation, and how we can write this neural network, how it looks exactly. Okay, these are things you will understand. So Alvin system. Alvin is nothing but it's an artificial neural network. Okay, they named it as a Alvin, and since it is a machine or it is a software or it is a algorithm or it is a network, that is artificial neural network, we just name it as a Alvin system. Alvin, okay, so it is a system. So it is providing us one example of artificial neural network learning. So this system is going to use that learned artificial neural network. Learned means this artificial neural network is completely prepared now, completely learned, completely trained, already developed. So why it is developed? To drive the car, to guide the or to steer the autonomous car or to direct the autonomous vehicle, driving at normal speeds on public highways. Usually we human beings drive our car on highways in the speed of 100 kilometers per second per hour, right? So in the same speed also this machine should drive the car. So, so the input to this neural network is 30 by 32, 30 by 32 grid of pixels. So what is this? You just observe, I am talking about input layer, input to this neural network. So what input we have to give to this neural network? We have to give some grid of pixels. That is nothing but set of pixels, and that also how much? 30 by 32. 30 by 32, if you multiply it, you will get some value. That many number of pixels we have to give to this neural network as an input. Okay, and from where we get these pixels? We will obtain these pixels from a camera, forward pointing camera mounted on our vehicle, on the top of our vehicle or inside of our vehicle. Now it is the first time we are attaching to our vehicle. In that space, wherever it is possible, there we have to fix one camera, and from that camera, whatever the data it is catching, the data will be input to this neural network, that is 30 by 32 of pixels, so that it can recognize the road, it can identify the curves, all those things clearly, so that we can increase the number of pixels here, no problem. So since this much is enough, we have considered only 30 by 32 feet of pixels. So okay, that the capacity of that camera is also 30 by 32 pixels. So here based on that camera, what that camera is doing, that camera is trying to give us some input, so that input we give it to neural network. Okay, so that camera should be fixed to our car, and that camera is getting really whenever the car starts to move, then similarly that camera is also continuously catching the inputs. Okay, that input will be in the form of 30 by 32 pixels, 30 by 32 grid of pixels, and these pixels will be input to our neural networks. And based on this input, that car is going to decide, or that machine is going to decide, or this algorithm system is going to decide whether I have to rotate my steering towards the right side, or whether I have to keep my steering in the straight, or whether I have to rotate my steering in the left side. These all decisions will be taken by this algorithm system. Okay. Now I think you got what input we have to give to our system. Now let us see what will be the output. Okay. So then our network will give us output. That output is nothing but the direction. That output is in the form of direction. So in which angle I have to rotate my steering of my car. So whether I have to rotate it towards the right side or left side, or I have to keep my steering straight, okay, without any rotation. So these all things will be decided, and these all things are output. So direction of car itself will be the output. And our ANN, that is artificial neural network, in short I have written here as ANN. Artificial neural network is trained in such a way that it can mimic or it can exactly copy our human driver who has shown some driving tips, or driving how to drive the car to our algorithm system, so that our algorithm system has observed our human being the driver for 5 minutes, and based on that 5 minutes experience, it starts to drive the car automatically. Okay, see what it is doing. Our artificial neural network is trained. Why it is trained? So that it can mimic or it can copy the observed steering commands. Observed steering commands means these are getting the experience. In the first class I told you how human beings will learn by observation, by experience, by practice. These all things we want to say, right? So here also our artificial neural network is learning something based on this observation. It has observed some steering commands by observing the human driver for approximately for 5 minutes in a straight highway or in a highway which contains some curves and all those things. Based on this 5 minutes experience, it can start to drive the car automatically. So Alvin has used to that Alvin has used this learned artificial networks to successfully drive the car to the speed of 70 miles per hour. 70 miles per hour, it is nothing but in bracket I have written for your understanding purpose. That is almost 112 kilometers per hour. Means it is a normal speed what we drive the car on highways. That is 100 kilometers per hour. And of course, how much amount of distance it has traveled? It has traveled around 144 kilometers. 144 kilometers means that Alvin system has driven this car for almost 1 hour 15 minutes, because in 1 hour it can cover 112 kilometers, but it has completed the distance, it has traveled the distance 144 kilometers. It means that it has driven the car more than 1 hour, maybe 1 hour 15 minutes or 1 hour 20 minutes. Okay, and where it has driven this car? On real public highways only. On real public highways, which is divided into two lanes, and left lane and right lane. And if it is India, it has driver left side, and if it is other country, it has a driver. It might have a driver in the other side. Okay, so and it was not alone on highway. Keep it in your mind. It was driving that car with other vehicles also, like tractors and other cars. Okay, so this much perfection it was got. Which system it is? It is a highway system. And how it has driving the car? Based on some observations of the steering commands of a human driver. Okay, and from where it is getting the input? It is getting the input from the camera. And how and in which form it is getting the input? In the form of pixels. And how many pixels it is? 30 into 32. You multiply it, you will get some value. That many number of pixels it was giving to our car as an input. And the output is what? Output is a direction in which that vehicle should be or steering should be rotated. Okay, so this is input and this is output, and where we are getting the input and how we are getting the input. Also, I told you, and how much distance it has covered, and which speed it has covered that distance, and all those things we have completed. Now, see how exactly these artificial neural network looks for this alien system. Okay, so there one figure I am going to show you. That figure is nothing but neural network representation, which is our main topic. Okay, neural network representation is used for this alien system. Okay, so in this diagram I am going to show you. In this diagram, three parts are there. This is one, this is two, this is actually four parts are there. This is three, and it is a four. See, this first part is just given for your just idea how exactly our dashboard looks like from the inside of our car. This is your steering, which is at the left side of car, which is a foreign car, and here camera is there. I think you are observing here the diagram is textbook diagram is somewhat black and white. You just see here, observe here. This is a camera. Okay, this camera is giving input to our artificial neural network. And how it is giving, see, when we switch on the camera, that highway looks like this. Okay, that highway looks like this, and this whatever the screen is there, which is visible to our artificial neural network, that is nothing but 30 into 32 pixel grid. So it means that 30 rows are there and 32 columns are there. Okay, you can observe here 30 into 32 sensor input retina. Sensor input retina is nothing but it is a camera, and which is producing the output, is producing the input in the form of 30 into 32 pixels. Okay, and here from here to here 30 32 pixels are there, and here 30 pixels are there. So total 30 into 32, how much it is? 30 into 32, 30 into 32, it is 960, almost 960 pixels are there in the screen, right? So here I have, let's see, this figure. Okay, 960 pixels are there, 960 pixels. So these all pixels are giving to the units of input layer as an input. And here some hidden layers are there, and four hidden layers are there. These four hidden layers are getting these all 960 inputs. Okay, 960 inputs, and then these are producing some outputs. Output is nothing but steering commands, right? And these outputs are giving to next output layer units as an input. Next here output layers are there. How many output units are there in output layer? 30 output units are there. Okay, this is these numbers of hidden layers and output layers are based on the problems, and they vary from problem to problem. So why it is only 4 hidden layers? Why it is only 30 output layers? It's not like that. It varies from problem to problem. Okay. See here 30 output units we are using, and here left side is there, and this one is a right side. It is a sharp left curve, sharp right curve. So it is nothing but so we are completely rotating our steering towards right side. We are completely rotating our steering towards left side. And here if the highway is very much straight, then the straight ahead is also there. So these all are decisions made by this output unit. Okay. So in 5 minutes this meeting will be ended. In the next class I continue definitely with the next topic. Okay. See here, here also one more third part is there. The third part is also the expanded or zoomed version of this camera. Okay. Here some black and white are there. These white boxes are nothing but positive, positive. What is that? Weights. Okay. So this third part is there. These are called as actually weights. Just remember W W. Okay. So these are weight values. These are weight values, and wherever you are looking here, that positive, that white boxes, these all white blocks are indicating positive weights. Okay, remember positive weights, and wherever you are looking, these black color blocks, so these are indicating negative weights. We will study these all weights and all these things. Don't worry. And of course, at last, that finally that modernized or refined grid once again we get, and it is very short and small grid. That is also which is a perfect output, which is a perfect output for our car. Okay. See. See, in general, this artificial neural network can be graph. Okay, graph with the many types of structures. See here, artificial neural network representation I am talking, right? So this artificial neural network, exactly they may look like a graph. Already you studied graphs in the third or fourth semester, I think. And these graphs may be cyclic graphs or acyclic graphs. So here these are graphs or artificial neural networks may be cyclic or acyclic, as well as they may be directed or undirected. Directed or undirected means arrow marks are without arrow and arrow mark edges. Okay, edges are with arrow marks and edges are without arrow marks. So these artificial neural networks will be represented in the form of graphs. Remember, okay, graphs may be acyclic or cyclic, and they may be directed or undirected. So now onwards. We are going to learn. Learning is nothing but choosing the weight value. Just now I have shown you the weight values. So those weight values we have to find out or determine for each and every edge in our graph. Okay, it means that every edge contains some weight, and those weights also we have to find out or determine. That is nothing but the main task here. That is learning. Okay, see here. Some hidden units level, see black and white boxes are. Okay, these are just now I told you black boxes represent negative weights, and the white boxes represent positive weights. Okay, positive weights and negative weights. So these all things we just go through these all things whatever I have discussed today with real time interesting example of autonomous was vehicle driving or steering. Okay, this problem we study today, and this is the representation of artificial neural network. Artificial neural network can be represented in the form of graph, which has some units or edge nodes with some edges. And for those edges only, we have to find out, we have to choose the weights. And that is what we have to learn here. Okay, and these graphs may be cyclic or acyclic, or directed or undirected. In the next class, I continue with the next topic. Okay, you can leave the meeting. Am I audible? Kaveri? Hello?